Hi, I'm Ted Nelson. I'm a software designer and I've worked on two major projects in my career. One is the Xanadu project, of which the latest version is here, which I believe is the generalization of documents and media. I believe it's the correct generalization of documents and media, but we won't talk about that now. I'm going to talk about the correct generalization of data structure. There are two traditions in data structure, really. One is the tradition going back to Fortran of the array, which was a one-dimensional list, and a two-dimensional table, and then extend that in space for a three-dimensional array, and then, four-dimensional array, five-dimensional arrays, which were used in the Fortran days. More recently, there are two principal conventions, both based upon rectangular tables: the spreadsheet and the relational database. Now, spreadsheet was created by, used to exist in business on paper, but then was created in its electronic form by Bricklin and Frankston. And it's wonderful till it gets too big. Because you see, as soon as you make a row across the sheet, it bisects the universe. As soon as you make a column, it bisects the universe. So suddenly you get these strange, cramped problems that you shouldn't have if you had a better construct. See, we're talking here about construct logic, designing arbitrary structures that are going to be the most useful. This is not about reality. It's about imaginary structures that are useful. Okay, another construct that's very significant these days is relational database, which was designed at IBM in the 1960s and 70s by a guy named Edward Codd. And he said it should all be tables of relations. He called them relations, even though we call them records. And he said he had all kinds of mathematical reasons and axioms you can read on the web, but probably it caught on because it was defensible against embezzlement, since different SQL programmers could read each other's code and check that they weren't playing footsie. But the problem is, you see, there's a fatal flaw in the database in the same way there's a fatal flaw in spreadsheet. The fatal flaw of the database is that everything has to be alike. Everybody has to have the same number of middle names because the record has to be the same width. Now, I'm told that wasn't required by Codd's original conception, but that's how it's been implemented. So essentially, that's how it is. So what I'm going to show you now is a way of dealing with irregularity without imposing regularity where it doesn't belong. Just as we shouldn't impose hierarchy where it doesn't belong, we shouldn't impose regularity where it doesn't exist. We should represent things as they truly are. Okay, so here we're going to look at hyperthogonal space, meaning orthogonally connected in as many different dimensions as you like. But that will turn out to mean something much more simple than it sounds. ZZ structure is another name for it. So here we have a conventional table, like a spreadsheet or a database. The same number of rows in every column, the same number of columns in every row. We have two views of it, which we'll discuss later, but let's look at the one on the right for the time being. So that's a conventional structure, and they say, well, you have to have this, everybody has to have the same number of middle names, and I say, why? Because we can create new cells that don't break the old connections. So as many middle names as you like. Notice this connection is still from the top of this one to the bottom of that one. So ZZ structure, or hyperthogonal structure then, simply allows you to create arbitrary constructions of cells, but they still have the same rule as in spreadsheet and other tables, that the top of a cell has to connect to the bottom of a cell, the left edge of a cell has to connect to the right edge of a cell in as many dimensions as you like. And we need different views. Now, these two views are both looking horizontally at dimension 1, vertically at dimension 2, but this is the row view, and this is the stretch vanishing view, and you'll see why that's useful. So now let's apply this to a specific domain. Here we are. We're going to look at the royal families of Europe. So I'll take both the blue cursor and the green cursor to this long column of royal personages, which start with Albert, and end with William Douglas Hamilton. In fact, you see, I can connect them. Sorry. Now try that in spreadsheet. But this is like spreadsheet in one way. Spreadsheet is taking the two-dimensional table and giving it views and operations. So here we are taking hyperthogonal structure and giving it views and operations, but it's much more general because it subsumes spreadsheet and database. Okay, so let's go now to someone we all know and take an interest in. Elizabeth II, reigning monarch of England. Oops, sorry. And now we have both cursors on Elizabeth II. You'll see now why stretch vanishing is useful, because it shows all the characters in a cell, whereas the row view is useful because it shows the regularity. Okay, now where does extra dimensionals, what does extra dimensions buy us? Let's pivot horizontally in the left-hand window to dimension date to see where she was born. So watch it now as we go along horizontally from dimension 1, dimension 2, dimension 3, and dimension date. And Elizabeth was born in 1926. No death date on the right. Is she married? Let's pivot in the right-hand window. Dimension 2, 3, 4, date and marriage. Sure enough, dimension marriage. She's married to Philip. Do they have offspring? Yes. Vertically now we're going to go to dimension 3, 4, date, marriage, and children, dimension children. So here we see how multidimensionality can give us the same cells and units in many different arrangements simultaneously. So you can arrange everything the way you like it in 2 or 3 dimensions and then create another dimension or 2, which arrange it all differently, doesn't change what's already there. The other dimensions are still the way you left them. Now let's take one more step. I'm going to move this over to the vanishing view. And now we have an actual walkable family tree. So let's see. There's Jan Willem, Prince of Orange. And go back, let's go back, sorry, to Elizabeth and see if I can find Victoria. I think she's up here someplace. Alexandra, Christian. There she is, Queen Victoria. So we took a walk from Elizabeth to Victoria on the family tree in Zigzag without ever leaving the structure. I'm not saying that this is the only and the perfect data structure. I'm saying, however, that it is a generalization of data structure which subsumes, in what I hope will be product soon, subsumes database, spreadsheet, timelines, genealogy, and a number of other structures, PERT charts. All of these things can be made simply as connections of cells in this structure by the addition of dimensions and views. This has implications for our culture and for our lives. We have been forced by the conventionally available software to warp and break the information we want to store. I think the most important thing is to give people the tools that will allow them perfectly to represent that information they have. The computer field is accustomed to falsely imposing hierarchy and falsely imposing orderliness and regularity on what is not ordered and regular, but has idiosyncratic properties and structures that go in all directions. And I say we must stop doing that. It is said that each generation recasts the past in terms of its own preconceptions, so that each generation looks at the past in a funhouse mirror that really represents its own present-day obsessions. I hope that in our archives and historical filings of the future, we do not allow the techie traditions of hierarchy and false regularity to be superimposed on the teeming, fantastic disorderliness of human life. Thank you.